In this video, we're only interested in finding or sketching the region R, whose area is given by the iterated integral, or you want to say double integral. Now this is important to be able to do because in some cases, in order to integrate a given double integral, you need to change the order of integration. Instead of dx, dy, it could be dy, dx. I think we looked at that at the earlier video. But here's the focus is just to sketch the graph of the region R. For the first one, let's look at the inner integral here. We don't have a function because we're only interested in the graph of the region R. So here this tells me for dy, these are the limits. So y will go from 0 to 2. So here's 0, y equals 0 would be the x-axis. Go 1, 2, and the x. dx then goes with the first limits here from 0 to 1. So that means x would go from 0, which is the y-axis, to 1. So y goes between 0, y equals 0, to y equals 2. X goes from x equals 0 to x equals 1. So the intersection of those would be this rectangle here. This would be to here. This would be 1. That's your region for the first one. Now for the second one here, x would equal to minus the square root of 1 minus y squared. If I square both sides, then x squared is equal to 1 minus x squared. This is y here. We'll take the minus y squared over, we get x squared plus y squared equal to 1. So I could solve for y, take this over, take the square root. I could say y is equal to plus or minus the square root of 1 minus x squared. Now this of course is a circle. Center is at the origin. Radius is 1. The positive gives me the upper half of the circle. Y equal positive square root of 1 minus x squared gives me the upper half. If I put a minus, that gives me the bottom half. Now if I solve for x, let's I get this one here with a y, and I put plus or minus the square root of 1 minus y squared. The positive value gives me the portion on the positive side of the y-axis over here, and the negative gives me the other half on the negative side. So if we look at this one here, x is going from minus the square root of 1 minus y squared to plus the square root of 1 minus y squared. So it's going to give me this portion here and this portion over here, but the y goes between 0 and 1. 0 and 1. You say this is a 1 there, minus 1 over here, 1 here, and a minus 1 down here. So x would be this half here, from this side to this side. But because y is contained between 0 and 1, that would be 0 and 1. The region we're looking at is that one right there. That'll be shaded in. And this would be your region R. And that's the region you would integrate over if you were given a function to complete the evaluation of this integral. Now for the third one here, y goes from x over 2 to 1. This is y equal to x over 2, and it goes to 1. So this is a line. Put in 0 there, I get 0, so that passes through the origin. If I go 2 units over, plug in a 2 there, get a 1 over here. So the line's going to go like this. Then y equal 1 is the horizontal line that passes through the point 0, 1, and it's going to go like this. The x uses these limits. That's going to go from 0 to 2. So where those two regions intersect, it'd be right here. So that's the region you would shade in. This is, of course, this y equal 1 right here. That's the region right here. That's the region you'd be integrating over if you were given the function to completely evaluate the integral. So this is the region for the third one. Now for the fourth one here, the y has these limits here. The x has 0 to 1. So the y goes from the square root of x to y equal to 1. And based on what they give us here, we'll be looking again at here in the graph in the first quadrant. So the graph of y equal to square root of x, it's a parabola that opens to the right, but it's only the top half of it because of what's given. If I go 1 over, this would be the point 1, 1. Again, the y value goes from square root of x, which is this curve, to 1. Y equal 1. So it'll be that line right there. Point 1 there. The x has these limits, so x is going to go from x equals 0 to x equal to 1. So x equals 0 is a y-axis. X equal 1 is over here. So the region of intersection here is right here. This area right here. That's your region R. And like I said, it's important to be able to sketch the graph of the region because there's going to be some double integrals where you can't evaluate them the way they're given. You'd have to change the order of integration. We looked at some of those already. Focus here, though, again, is sketching the region. Thanks for watching. We'll see you next time.